All right. Good morning. Let's see here. This was Unit 5, our Unit 5 test review, and this is the third page. Third page, Unit 5. Here we go. Solve for the missing variables. I see an X and I see a Y here. Now, one thing to note on this one, this is called a mid segment. All right, this piece that's kind of halfway up here. This is a mid segment. This was something we talked about in section 5.4. All right, we said a mid segment was the segment that is created by connecting two midpoints. So if I call this point M and I call this point N, all right, those are midpoints on the triangle. Maybe this is triangle A, B, C. All right, so M is the midpoint of AC, N is the midpoint of AB. And I know that because we have those tick marks in there. So AM is congruent to MC, AN is congruent to NB, that sort of thing. All right, there was a special relationship between a mid-segment and a base. All right, so the first thing we could say is MN is parallel to BC. All right, so I'm just going to throw some parallel symbols in there. That's going to be useful for the second part here. And then the other part we said was MN is equal to MN. There we go, is equal to half of the base, is equal to half of BC. All right, so for example, if BC or CB has a length of 10, all right, MN would have a length of 5. All right, so we're just chopping it in half. All right, that's how we could figure out the mid segments. All right, the length of the mid segment here. So looking at this kind of expression here, if I say x minus 1 equals x plus 9, all right, that would be wrong, okay? We can't set them equal to each other. MN obviously shorter than BC. So here's what we need to do. I need to take MN and I need to double it. All right, I need to multiply it by 2. And notice how I put the x minus 1 in parentheses. That is important because I need to distribute this to both of those terms. So I got a 2x minus 2 equals x plus 9. All right, and now just standard solving from here, subtract an x, add a 2, we're going to get x equals 11. Now, if I want to, again, kind of confirm that, what I say is true, plug in the 11, x minus 1 or 11 minus 1, this is a 10. All right, x plus 9 or 11 plus 9 gives us a 20. All right, so that agrees with what we are talking about. All right, so MN is 10, BC is 20, right? It all works out. Now, the next one, solving for y. Here's what I'm going to do. These lines are parallel. I'm going to pretend that I drew some straight lines there. This is angle y. This is a 63-degree angle. Now, parallel lines. What do we remember about parallel lines? All right, so this is a Unit 2 idea. We had alternate interior angles, alternate exterior, same side interior, same side exterior, and corresponding. So there are 5 things to think about with something like this. And we had to think about what was this pair. Now, just looking at those, one's acute, one is obtuse, so they can't be congruent. So if they weren't congruent, we said that they were supplementary. So we can say y plus 63 equals 180. All right, just subtract the 63 from both sides, and we're going to get y equals 117. All right, 117. That's a Halo reference if you guys are video game fans. And there we have it. I mean, the whole idea we could do that was because we had some parallel lines in there. MN is parallel to BC. We know that because it's a mid-segment. That was one of the 2 properties we had here. All right, and there you go. That's how we would solve for x and y on that one. Moving on to the next problem, an isosceles triangle. So that is probably going to be important. So isosceles triangle LMN. So here's what I'm going to do. I'm going to draw. There's a bug flying around. Let me try that again. I'm going to draw triangle LMN. right? And it's isosceles. They're saying L is the vertex. Keep in mind, vertex angle is the not congruent angle. So I'm going to put M down here and N down here. Since it is isosceles, these two sides are congruent. These two angles are congruent. And I know that because it says L is the vertex. All right, since L is the vertex, that is the non-congruent angle. So that means M and N have to be the congruent ones. And then the opposite sides from those angles have to be the congruent angles as well. Now, we know M and N are congruent, right? Easy enough. So that M and N are congruent. Angle M is congruent to angle N. Well, since the angles are congruent, that means those expressions are equal. So I'm going to say, all right, 76 is equal to 3x plus 1. And let's solve that. 75 equals 3x. Divide both sides by 3. We have x is 25. Now, we're not done, right? They want us to find x, and they want us to find the measure of angle L. So here's what I need to do. I need to go back in and figure out what these angles are. Now, angle N we know is 76. All right, they just tell us it's 76. So we don't even really need to do any math to figure out the other one. This angle is also 76, right? Because they are congruent. We could plug x back in and we could, verify that. But we need to figure out this angle up here. Maybe I'll call that y. Well, what do we know about triangles? Every single triangle, no matter what it looks like, equilateral, scalene, isosceles, whatever you want. All right. You take all three angles and you add them together, and they are going to equal 180 degrees. That is that triangle sum theorem. I think that was the first thing we proved in this unit. All right, so let's just make that equation and solve for y now. So 76 plus 76. 70 plus 70 is 140. 6 plus 6 is 12. So that's going to be 152. 152. All right, so y plus 152 equals 180. Subtract the 152 on both sides. What will that give us? I think, ooh, that looks bad. Let me try that again. Y should equal a 28 here. All right, 28 plus 152, that gets us to 180. All right, so that one's good. All right, so angle L, and instead of saying y equals 28, let's just say angle L equals 28. All right, and there you go. That one's done. All right, on to the next one. BE is an angle bisector of triangle ABC. All right, so here's what I'm going to do. I'm going to draw triangle ABC here. All right, I don't really know where A, B, and C is, so I'm just going to put A right here, B right here, and C right here. All right, so it says BE is an angle bisector. Nowhere on here do I see a point E. All right, all I know is BE is bisecting an angle. It's bisecting. What is it bisecting? BE. Oh, sorry. So E, so here it has to start at point B, right? And it's got to go this direction. Now, where is E in this picture? It doesn't really matter. You could draw it right here if you wanted to. So I'll just put an E right there. But keep in mind, what are we bisecting? We are bisecting angle B. All right, so these two angles here are congruent. So we could say angle ABE is congruent to angle EBC. All right. Fly is back. All right. Let's see here. We know EBA. I don't know if you guys can see that. There's a little gnat flying around, and it is driving me crazy. All right, sorry. Anyways, EBA, so angle EBA. All right, so that's going to be that top angle, and then ABC. Notice how ABC is the whole thing. All right, so I cannot say angle EBA equals angle ABC. Right? If I do this, that would be incorrect. Notice how EBA is just that top angle where ABC is the entire angle. So what do I need to do? We need to double angle EBA. All right. So we know what EBA is. It's just this 6x minus 13. So here's what we can do. Just plug it all in. So 2 times 6x minus 13. That is going to equal ABC as 3x plus 1. So that's key. So there are going to be, I think there's 4 problems on your quiz, or on your, well, your quiz, but this is your test review. There were several problems on your quiz that were just like this. I give you like a triangle and I tell you, hey, which one was it? There are a lot of terms in this one. We had a mid-segment, a median, centroid, angle bisector, altitude, perpendicular bisector, right? So we had to, using the term, we had to figure out what the setup on these pictures kind of look like. And that's the key. That's the whole idea of these problems is, giving you this information and seeing if you can set up these equations. All right, so we got 12x minus 26 equals 3x plus 1. All right, and then we solve it. So I ran out of room. Let's go up top here. If I subtract 3, we got 9x. And then I'm going to need to add a 26. That gives me a 27. 9 divided by 27 is 3. And so x equals 3. Now, are we done? We are not done. If you end here, I got to take off a point because we want to find angle EBC. Angle EBC. Well, notice how angle EBC is congruent to angle ABE, or ABE is the same thing as EBA. So let's just plug x into this guy right here. So angle EBC is equal to 6 times 3 minus 13. All right, 6 times 3 is 18. So we got 18 minus 13 equals 5. All right, so that is a 5-degree angle. All right, so skinny angle. All right, on to the next one. In triangle BOY. Triangle BOY BZ is a median. So here, I'm going to draw a triangle BOY. I don't know what kind of triangle this is. Maybe it's equilateral, maybe it's isosceles. I don't know. I don't really care. All right, I just need some kind of picture to help me out. So here is BOY. And they're saying BZ is a median. Keep in mind, what is a median? A median starts at a vertex. In this case, it's going to start at point B because, it has B in the segment name. And it needs to come down to the other side. And it hits a midpoint. So in this case, I guess Z is our midpoint. Well, what do midpoints do? It chops a segment into 2 congruent pieces. So we know OZ is congruent to ZY. All right. So let's see what we got here. YZ is x plus 15. ZO is 11x minus 25. All right. So YZ and ZY, those are the same thing. Remember, there's that symmetric property there. So why don't we set these expressions equal to one another? So we got 11x minus 25 equals x plus 15. All right. So there's kind of our setup. These segments are congruent, so the expressions are equal. I'm going to come up here now. Subtract an x, I got 10x equals, add a 25 over 15 plus 25 gives us 40. Thus, x equals 4. All right. Step 1 is done, right? That was the hard part. Don't skip the easy stuff. Find yz now. So let's plug it in to this expression, all right? So yz is equal to just 4 plus 15, or 19, all right? So this is 19. Now, we don't need to do any math to know that OZ is. OZ is just 19 because they have to be congruent, right? So ZO, or OZ in this case, also equals 19. And I know they're not asking for it, but OY is just 19 plus 19, or 38. Right? And that one's done. All right, so I think these are the last three, last three on this page. All right, so triangle WAX. All right, let me try that again. All right, so how about this WAX? All right, there's your triangle WX. WN is an altitude. What did an altitude do? An altitude started at a vertex, and it goes straight down to make a 90-degree angle with the opposite side. So since W is part of the segment name, I'm going to start at the vertex W, and we have to go straight down. I'm going to pretend that that's a straight line. All right, and it has to make a 90-degree angle. All right, so we know angle W, what, this is an N, WNA equals 90 degrees. We also know angle WNX equals 90 degrees, right? Those both have to be 90 degrees because we have perpendicular lines. All right, so let's look at this. WNX. WNX is 2 times x minus 5. So let's set those two equal to one another. So we can say 90 equals 2 times x minus 5, and then solve here. So we could say 45 equals x minus 5. So what I did there is I divide both sides by 2 instead of distribute. That might save you a little bit of time. Or x equals 50. All right, so that looks bad. Let me try that again. X equals 50. All right, so I divided both sides by 2 there. I haven't done that much this year, like showed you how to do that. So let's just do it again. So 2 times x minus 5. What you could do instead, distribute the 2 in, right? We're going to have 90 equals 2x minus 10. Right? Add the 10 over, 100 equals 2x. Therefore, x equals 50, right? So it really doesn't matter which way you do it. All right, I'm not using a calculator, so I would divide instead because I like smaller numbers. Smaller numbers are easier to work with, just kind of mental math. Right? Does not matter which way you do it. The green way is a little bit more efficient, but it does not matter. All right. Find the coordinates of the centroid. So remember, the centroid is where the medians intersect. And we had a nice little formula for this one. The centroid, it was kind of like the midpoint. The midpoint was the average of the x's. The centroid is the average of all 3 points. All right, so the x centroid, the x coordinate on the centroid is x1 plus x2 plus x3. All right, we take that whole thing and we divide it by 3 this time. So remember, the centroid is you're just finding the average of your x values and the average of your y values. And in this case, we have 3 values. So that's why we are dividing by 3. So y1 plus y2 plus y3 divided by 3. All right, so that's what we're doing on 23. We just need to figure out what are these ordered pairs here. So P, point P looks like we're at -4, 0. Point R, that's a nice one, we're at 0, 0. And then Q, we are at 3, -4. All right, so let's do this. I got -4 plus 0 plus 3, all divided by 3. That gives me -1/3. All right, so about 0.33, -0.33, repeating, of course. All right, and then your y values, I get 0 plus 0 plus -4. Divide that by 3. That gives us -4/3, or if we were to graph that, that is -1.333, repeating. So if we plot this point here, so the ordered pair is negative 1/3, negative 4/3. All right, this is my centroid. Let's just look and see where that is. I got negative 1/3, so I'm going a little bit to the left, and I'm going a little bit down. So that's going to go right there, approximately. That is going to be, I'll call that point C for our centroid. Now, keep in mind, what does a centroid do? It connects the midpoints. So here's a midpoint of PR. Here is roughly a midpoint of RQ. I think it should be a little bit lower. It's going to be right here. And then the midpoint on this guy is going to be roughly right there. So if we make all of these medians, I connect the midpoint with the vertex. Right? Look where all three of them cross. This is our point of concurrency. All three medians cross at that centroid. Right? That's what the centroid is by definition. It's just where the medians intersect. All right, so that's how we do it. Number 24, the same exact thing. I just don't give you a chart. All right, so we know the x centroid here. I'm not going to write down the formula again. It's just add up all the x values, negative 4 plus 5 plus 0 all over 3, right? These are your x values. Gives us 1/3. All right, same thing with the y values. The y centroid. Oh, we got 0 plus 0 plus negative 6. Divide that by 3, that gives us a negative 2. All right, so the ordered pair here is 1/3, negative 2. All right, and that one's done. That's how we find our centroids, right? We don't need a graph. If I just give you all 3 points, that's all we need. Just plug them into that formula. It's the average of the x's and the average of the y's. All right, but there you go. That was page 3. All right, so we got one more video, so I'll see you guys in the next one.